Next topic is the measurement of state. So in this case, the state is defined as is the water surface elevation measured by above datum. So from previous we talk about the assumed datum, another datum we call mean sea level, MSL or lot of core. So respect to the sea level. And in for measurement we have to classify into the manual gauge or automatic gauge recorder. For manual gauge we have to stop gauge or wide gauge. Stop gauge is we put the gauge attached to the for example embushment, this one put to the embushment of the bridge and measure the water level from this tap, or if the depth of the river is very deep, so we can divide into different, because segmental stop gauge, too many stop gauge. Okay, and for y didn't have any detail of this is mean y gauge. This mean we measure, we put the y from the bridge to the river to measure the depth of the water. For automatic state recording, is the first type is we call the float gauge recorder. So we put some float here on the surface and measure the record. Yes, the recorder measure the level of the float using the we call the steering wheel. Okay. The other type we call the bubble gauge. Okay. There's like a small pump to pump the air through at the bottom of the stream, and there's a bubble from the pipe, and from the number of the bubble or from the pipe can convert back to the depth of water, because if the higher depth is mean high pressure, and small bubble because of high pressure. Okay. This is the state hydrographs of the results we have. Is we want like this is mean the time and the state in terms of elevation of the water level. The next measurement of the velocity we can measure using the float by float. Okay, for example, if it is very small, the graph is small stream, a small canal, we can like put the start and end point, start and measure the length between starting point and ending point. This is we can start to put the bottle in the canal and stop the time when it's passing through this point, and we know the length and know the time, so we can estimate the velocity. And for the depth, for the area, we can measure the depth of the canal and take the average of depth and time the width. We can know the area, flow area. Okay, so this based on this we can the velocity of flow is length divided by t, and we can find the depth average, and for the area is equal to width times depth average, and q is equal to area times average velocity. Okay. This we can measure using this float. Is a lot float or canister float, okay, or surface float, because we know that the velocity is not the same in the same river. For the different depth of the river, the velocity is not the same. Okay. Another method we call the dilution techniques. So this one is for to measure the stream flow measurement. Is a chemical method depending on the continuity principle applied to the tracer. So tracer is mixed with the flow. There are many three main types of the tracer. The first is chemical, salt, sodium dichromate, or fluorescent dye, or we can use radioactive material. Okay, so we can inject the tracer. So for example, we inject salt with the known concentration, and at the downstream of the stream, the flow, we can correct the sample and measure the concentration again. From the region of the source or tracer, we can, and the length from the upstream to downstream, we can convert back to the stream flow based on this method.